Today's lesson is 12.9, Subtracting Mixed Numbers. The objective is, I will use models and computational procedures to subtract mixed numbers. First problem we're going to take a look at says, how can you subtract mixed numbers? A golf ball measures about 1 4/6 inches across the center. What is the difference between the distance across the center of a tennis ball and the golf ball? Choosing the operation. So we have to subtract to find our difference here. Well, I know with subtraction, I always start with my larger number, so I'd have 2 3/6 minus whatever the smaller number is. When we subtract mixed numbers, there's something we always have to pay attention to, and that's the fractional part. So I always have to stop whatever I'm doing before I start actually subtracting anything, and I take a look at my fractional part. I know that if my bottom numbers are the same, that part of my fraction stays the same. But then I subtract my top numbers. Just like with normal subtraction, I cannot do 3 minus 4 because 3 is smaller than 4, and that would not even be possible. So instead, what I have to do is I have to borrow. But our borrowing is going to look a little bit different. I can borrow from my 2, and I'd borrow 1 whole. So my 2 would become a 1. If I am borrowing a whole of 6, I am borrowing 6 6. So I actually end up adding 6 6 plus 3 6. So I'm going to add 3 plus 6, and I would get 9 6. So now my new subtraction problem would actually be 1 and 9 6 minus 1 and 4 6. Now I'm actually ready to subtract. 1 minus 1 would be 0. If I get 0, I don't have to write it, but I'm going to go ahead and write it. My denominator stays the same, and then I subtract 9 minus 4, and I get 5. So for this one, my actual answer would just end up being 5 6. I wouldn't really worry about writing the 0. Would just write my 5 6. It seems complicated at first, but I just have to pay attention closely to the numbers that I am subtracting. So we're going to try a couple more. So I want you to go ahead and write down these ones in your notes. The first one we're looking at, 2 3/8 minus 1 7/8. Well, again, I take a look at the numerators of the fractional parts first. Well, I cannot do 3 minus 8, so I borrow 1 whole from the 2. So 2 becomes a 1. I add whatever the denominator is, because that would be my 1 whole. So I'd be adding 8 eighths. So I add it to my top number, which would give me 3 plus 8, giving me 1 and 11 eighths as my new first fraction, or first mixed number, minus 1 and 7 eighths. Well, 1 minus 1 again would be 0. This time I'm not going to write that down. 11 minus 7 would give me 4. My denominator would be 8. Well, on this one, if you're working on simplifying, or you know your halves, you know that 4 is half of 8, which means I can divide both the top and the bottom by 4, which would give me a final simplified answer of 1/2. But again, if you ended with your answer of 4 eighths, I would accept that as well. Let's try this second one. It's 5 3/6. 5 3/6 minus 2 4/6. Well, yet again, this is smaller than this, so I have to borrow from that 5, making it a 4. Again, I always add whatever my denominator is, and that can change for every single problem. So for this one, I'd be adding 6 6, so it'd be 3 plus 6. So I end up with 4 and 9 6 minus 2 and 4 6. Well, when I subtract this time, I end up with 4 minus 2, which gives me 2. 9 minus 4, which will give me 5. My denominator doesn't change, so my final answer would be 2 and 5 6. Taking a look at this first problem here, says that Charles uses 1 1/3 cups of blueberries and 2 1/3 cups of cranberries to make a breakfast bread. How many cups of blueberries and cranberries did he use in all? Okay, so for this one, I would actually be adding them. So we're going to kind of review a little bit. So I'm going to take a look at everything I have over here in the visual, because I have 1, 2, 3 wholes, and then I look at my fractional parts. I end up with 2 thirds. So that's a quick review on adding. Now we're going to take a look at a subtraction one. It says, Eva ran to her friend's apartment in 2 and 4/6 minutes. It took Eva 4 and 3/6 minutes to go back home. How much more time did she take to go back home? So we would take the time that it took to get home minus the time that it took to get there and see what we have left over. If I take a look at my visual, they're already subtracting out the 2 wholes and 4 total 6, which leaves me left with 1, 2, 3, 4, 5, 6. So on this one, I got to use the visuals instead of doing the borrowing. But if I did the borrowing, I would end up with 3 and 9/6 minus 2 and 4/6, which would still leave me with the answer of 5/6. In your notes, I would like to see you go ahead and give number 1 and number 2 a try and have it ready to share.